So, good evening, MarieDass. I'm very happy to see you.
Hello.
So, for sir, it's good morning. For all of us, it is good evening. I would like to welcome sir for our session, computer science session. And sir, I would like to tell you all students are extremely excited to listen from you, as this is a very now that's our point of interest, definitely, because this is what sir is going to discuss, and he has a lot of passions. He loves teaching, which is really, my students are blessed to have you right now, as it's your passion to teach, and you are expert in RDBMS. That's the topic that we are going to discuss. So we are very happy to have you, sir, here, an expert handling the topic. So I welcome you, sir, and I hand over the class to you to start the session.
Sure. Thank you, ma'am. It's my pleasure to be here with all of you guys. All right, so I don't need more introduction. I was preparing some, but I know Madhavi madam gave a very nice introduction. So thank you so much. All right. So I know this is kind of a different scenario. You know, it's not a classroom session. It's going to be online. So if you guys have anything, like we have the chat open, you know, feel free to stop me. You know, if you have questions, you can put it on the chat. If you feel I'm going too fast, too slow, let me know. Now, basically, I did not want it to be a very formal session, but at the same time, I wanted to make sure you guys understand, take away something from what I speak. Okay, it's been a long time. Okay, before I get there, hope everybody is doing good. I know we have a very different situation now. Everybody is staying home, staying safe. That's very important. So make sure you stay safe. That's the base for everything. Assuming that everybody is doing good, let's keep going. So some of the ground rules I want to set. Number one, I don't know anything. Okay, let's start with the base rule. Feel free to ask anything that does not mean you should not ask. So you ask anything that you want to. I would generally say it could be related to the session, maybe something outside of the session. If you have some questions that you want to talk in general, something related to some kind of thought or you know, something that you want to understand, feel free. Like I said, I may not have answers to. I would appreciate if you guys go on mute. Or I can mute you all from here. Whoever joins, can you just go on mute, please? I'm gonna mute. Okay. So feel free to ask whatever you feel like, and then we'll take it from there. Okay. And the other ground rule I usually expect is I would expect it to be interactive. You know, it's not only just me talking, then it gets more boring. And so I want you to be involved and interactive and to have some amount of interest. You know, even if you don't understand anything that I speak, just listen to the stories. I'll try to fit in some stories here and there. Just at least take the stories away. Okay. All right. I think with that said, let's slowly start moving. You know, there's only one. You know, maybe one of the secrets I want to share today. You know, do not study. Okay. I said, do not study. I know some of you are surprised. What is he talking? But I didn't finish my statement. Okay. So I said, do not study just for the sake of studying. But when I mean just for studying, not only for the marks. Okay. I know marks is important, but don't just study for the sake of marks, but also for understanding and its purpose. There's only one thing I'm going to ask you today. Okay. When you go along with me, maybe the next couple of days, a few days, marks are important. Okay. Marks are certainly important. Unfortunately, that's a measuring factor. So that is important. But don't just stop there. Not only for marks, but also for understanding and purpose. What I mean by understanding and purpose, understanding is what is it? And I'm going to mute all of you. Okay. So what I mean by understanding and purpose, understanding basically means you have to ask questions like, what am I studying here? We're talking about DBMS today. So what is DBMS? And the second part of it is the purpose. What is the purpose of this course? Why am I studying this? Where am I going to apply it? When will I apply it? And how is it used? It's basically like I said, you guys are aware of the 5W1H rule. Apply the same to anything. Okay. So these are two things I always say, not only for DBMS, for anything that you go through, ask to understand and ask the purpose of it. Okay. When I mean by understanding, I'm going to talk about DBMS concepts. Okay. So these are going to be like what I'm going to talk for the next few days is more about pillars and the beams of the building. But you have to understand that and then build on top of it. When I say what is 2 plus 2, I can teach you today what is 2 plus 2 is 4. If you understand only 2 plus 2 is 4, you're not going to understand how that makes it 4. There is a technique behind it, right? How 2 plus 2 makes it 4. How 3 plus 3 makes it 6. So today, that's what I'm going to do. I'm going to tell you how 2 plus 2 makes it 4. What I want from you is not just understand 2 plus 2 is 4. How 2 plus 2 is 4. That how part is very important. Again, remember our base rule. If it is boring, you have to stop me. Okay. Any point of time you think we are losing interest, somebody has to ping me on the chat. Feel free. Don't worry about what Madhvi madam will say, what Murli sir will say. Just ping me here. Sir, can we talk something different? Then I'll be happy to do that. Okay. I'm good at talking, so I can talk different topics. Okay, going back. So I want you to understand not just 2 plus 2 is 4, how 2 plus 2 becomes 4. When you understand that, you're going to make tomorrow in the exams, somebody is going to ask you, what is 2,846 plus 4,832, let's say. You cannot go and say, oh, look, they didn't teach me what is this number. I know only 2 plus 2. Unfortunately, that's where we are going towards, right? I'm not blaming anybody here, but mostly that's what it is. We just understand, or we just take away what is being told. 2 plus 2 is 4. That's all I know. Don't ask me anything outside of it. But that is not going to help you as you go down the line. So ask me how 2 plus 2 makes 4. Then you can do any addition. Yes? So let's use that base rule. Try to understand what I'm speaking. If it doesn't make sense, feel free to stop me. Say, I don't understand this. Okay? All right. The reason why understanding and purpose is important is because it's more like making friends. If you're going to just understand what is DBMS, leave it here, thinking, oh, no, I'm not going to use DBMS. A lot of times when I was studying, I used to say, I'm studying a subject. I don't think I'm going to work in this subject. So why should I understand this? I will just study to score the marks and just keep going. But I think it's late in the game to realize you should have understood that. I always say it's more like making friends. Let's say you were in 10th grade, you made some friends, you drop the friends, you
Hi.
go ahead. Somebody wants to talk? There is a little. All right, sorry, I lost you guys for last 10 seconds. Did somebody have a question? Okay. Okay, I'll assume that as no and keep going. But again, if you have questions, feel free to. I've muted everybody. So if you need to speak, you need to unmute yourself and talk, or you can ping me on the chat. Okay. So I was talking about, how we make friends, as we go through each phase of our life, we make friends, right? It's not like you make a friend, you drop them there. 10th grade, you make a friend, you drop them. You go to PU first year, you make a friend, you drop them. You go to PU second year, no, it's not like that. As you make friends, you keep them carrying along your life, right? That's very important. You need to carry your friends as you go along the life. So same way, any concept that you study, you need to understand and carry that along, okay? Studying is like making friends. carrying them along is like maintaining them, right? So both are important. So DBMS, you might think it's yet another subject, but believe me, me and DBMS have interaction for last 20 years. I think it was about 20 years now, and I still use it every day. When I first learned, I just thought it as subject. Okay, I just thought it's a subject. But as I understood more and more, and as I started using it practically, I'm seeing it's used in every single walk of my life. You name it, it has DBMS behind it. You may not know that you're using it, but it's behind it. In everything that you do, you know, there is DBMS behind it. DBMS is database management system. So same way, you never know, you might be building a career yourself in DBMS. So any subject for that matter, I'm not just saying only DBMS. Any subject for that matter, you never know. That subject might end up to be your career. So try to understand, define a purpose for that subject, and keep rolling along, and don't study just for the sake of marks. Okay, so that's my one line. So I just remember I said do not study, but I didn't stop there. So I had a comma there. I said do not study just for marks, plus for your understanding and purpose. Okay, this is very important. Believe me, it's true. Today's world, I use a lot of concepts that we have studied, that when we studied, we didn't know that we're going to use it. Okay, all right. And again, you know, studying is different. What is the sole purpose of you guys studying now? So you guys are going through PU. What's next? After PU, you go into some professional courses. You take up some profession. So right now, it's you're called student because you study. Studying is student. And the ultimate goal is to go into a job or a work, right? Why is it called work? Because you go work there. You have to go work. You cannot just go and come, right? You have to work there. So for you to work, you need to know what to do. What you do there is what you study here. Okay. So that's what I'm trying to say. What you study here is what you're going to apply in your job. So try to correlate that. Okay. It's not, yeah, I'm studying. Why? Because I need to pass the grade. I need to get PU qualified. I need to go for a course. No. Look at a long-term goal. What is the purpose of this course? I'm going to apply it in my job. So if you correlate that today, you're going to think everything in terms of your job. Assume that you're employed already. You're sitting in a job. How will I apply this in my job? You can ask me that question. I can talk from that perspective. Like I said, teaching is my passion. I love talking and teaching if I know subject. Okay. So you can ask me, how is this applied? My distance from teaching to students like you has been quite some time now. But applying it on a daily basis, you can ask me, how is this applied in today's world? I can throw some examples. Okay, I've worked through some major clients and major projects where they're applied. So I have some exposure to explain. That might give you knowledge. And that's not just studying what is what, but where is it applied? How is it applied? If I explain that, for example, simple example, you go to ATMs, right? You go to ATMs, use ATMs. Where is the data coming from for ATM? When you go push your buttons on the ATM, or when you go put your card into the ATM, it is at the background, it's invoking a DBMS. It's talking to a DBMS. It's talking to a database. It's basically converting a question for you. The ATM is converting a question for you back to the DBMS saying, look, there is a person standing in front of me who's carrying this card number. He wants to do this. Maybe withdraw some cash or deposit some cash or check what's your balance. So each one is translated a question, and at the background, it is talking to a database, right? It's a simple example. So every day now, you go to an ATM, you're gonna think, oh look, I'm talking to a DBMS here, right? You go online, you book your airline tickets or any ticket, you book your railway ticket, whatever it is. At the background, you're asking, is there a seat available? Is there a ticket available? What are you doing? You are at the background, the system on your behalf, system is talking to the database, asking a question. Somebody is asking with this name, is there a seat available? He wants to fly from, let's say, Bangalore to Chicago. Is there a ticket available? So that is what is happening at the background. So these are some of the examples. We'll see more as we go through. I'll talk through some of the examples. So what I'm saying is anything, it's not only DBMS, anything that you study, try to correlate in practical life. Where is this applied? How will I apply this in my job? Start thinking about your job. Start thinking about what you want to do. I'm sure you are in a very critical, crucial phase of your life where you're going to make decision about what profession you want to go into. So by now, you must have decided what you want to do. So apply, bring that profession, start dreaming that you're already into the job. Live in that world. I'm telling you, believe me. Excuse me. I'm sorry for my coffee, but that's my morning coffee. So live in your dream job. Create your dream job, live in it. As you live in it, apply your concepts there. How can I apply in my dream job? And again, we'll talk more about this as we go down the line. Okay. All right. Like I said, if you start understanding the concepts, it's going to help you in your career decision. If some of you are still not clear about, I mean, it happened with me, to be honest. When I was doing my 10th grade or PU, I don't know, I would be a IT professional. To be honest, I hate coding. I should say, I hated coding. Okay. But today, a lot of codes that are deployed in production that are running, in the client that I work for has my name on it. These are very old codes, 10 years old. And I go back, I look at it. I developed some of the codes from the base. When I look back about 20 years back, I never thought I'm going to be an IT professional. So life changes. Okay. So you have to create something for yourself. You are in a very crucial decision point. Make a decision what you're going to do. Understanding some of the concepts in the subject might help you. Like today, if you understand, let's say DBMS, you might start thinking as you explore, as we go down the line, let's say as we finish this course, you might start thinking, how is DBMS applied in practical life? One day it might strike you, oh, look, this is something I want to do. Why don't I explore? So then you start exploring, then you start learning more. So today it's going to be a top-down approach, meaning you are learning the subject and trying to think, how is it applied? The moment you decide what you want to do, you're going to do a bottom-up approach, meaning I want to do this. What do I need from doing it? Like how much of DBMS should I learn? What more should I learn in DBMS to apply this in my career? Make sense? So what I'm trying to say is as you understand and do a purpose for your learning, it will help in making a decision for your career, right? Make sense? I just want to pause to see if you have questions, concerns. Am I talking? If I usually have a feedback, I talk too fast. I have learned to talk slow a lot. So if you guys still think I'm talking too fast, or if you don't understand what I'm talking, please, drop me a message. If somebody could just ping me saying everything looks fine, I'll keep going. Even if not, I'll still keep going. Okay. But I would be happy if somebody tells me, or you can just, unmute yourself and say, yes, everything is fine. If you have questions. Okay. So I have Gahan and Gautam pinging. Everything looks good. Perfect. Okay. Thank you guys. So let's keep going. So again, I keep reminding the base rule, the ground rule. Anytime you're bored, you gotta ping me, say, can we talk slightly away from the topic? I'll try my best to keep it interesting. DBMS is not very dry subject. It's not like something you don't even understand. You have to just assume a lot of things. No, it's not. It's more like like I explained. It's something that's used every single day. Okay, so it should be easy. So anytime, remember a ground rule. Okay. So shifting slowly towards our topic of today's discussion, database. What is database? I usually have this technique, I tell people if you don't know what it is, read it in reverse. So what is database? It's basically a base of data. Okay, it is a base of data. So what is a base? Base is something that holds basically where everything is located. So we talk about military base, we talk about naval base. So what is a military base? Where the whole force is located, where we have everything based out of there, everything operates from there. So it's basically the source of that operation. So same way here, database is basically base of data. What it means is that base holds the data from where it operates. Make sense? So all the data is going to be dumped in one place, and then we're going to take it from there, trim it, use it, if I can use the term, make it up. I'll use a technical and professional term as I go down the line, but for now I'll say it's like makeup. More the ladies do the makeup. you know so the originality is different, but the made up structure is different. So same way, no offense. So you make up the data. Okay, the data is in raw form, you make it up and then present it. So it's gonna stay there. So that's what is databases. So it's in short form for today, it's a base of data. It's the base for the data where the data resides. Okay, as I go down the line, I'll talk more about how to use it in your, as you have to define it. Okay, and what more we will study is about how the data has evolved. Okay, I keep using the term data. Like I said, as I keep going down the line, I'll make it more clear. But for now, what is data? Data is nothing but some kind of a number, a fact, a statistics I might use. It's just a figure. Let's say it's 20, 30. I don't know what is 20 or 30, but it's a fact, right? Let's say 40 degrees. 40 degrees is a number. So it's it's a statistics or a number or a fact. For now, let's assume that's data. Now, this data has to be stored somewhere, right? So I have some data on my hand. I need to store it somewhere. So where do we store it? That is what we're gonna talk as part of this course today. So I want to talk about how the data has evolved. How the data has evolved. I'm sure you use the term evolved, evolution. Evolution basically how things have changed. Like, we keep saying man evolved from maybe monkey. So how that has evolved, you might have seen some pictures, in the olden, ancient times, we were walking on four legs, and then slowly we started walking on two legs. We were walking bent. Then we slowly started, walking. Now we're walking two legs. I don't know what we evolved into. My daughter keeps telling that birds evolved from dinosaur. I don't know true or not, but she says it's true. So the birds today that's flying is evolved from dinosaur. So in olden days, we had dinosaurs. They slowly evolved, and they got wings. They started flying. Now, so same way, the data evolved. The data storage, I should say, has evolved. How is it is evolved is basically, I might need to take you into the history a little bit. In my olden days, if I go back like 20 years old, how was the data stored? Anybody wants to take a guess? How olden days, how was the data stored? In our great grandfather period of time, how was the data stored? So somebody said verbally, orally, yes, plus in paper forms, yes. Somebody, thanks Nagesh. Nagesh said books, records. Danyata, thank you. I'm sorry if I said that name wrong, but records, yes. When you mean my books, records, what? They are on papers. So basically, they started writing in papers. Anything that you say today, in olden days, they write it on paper, store it. Write it on paper, store it. So that's the first form of data storage, but it became very cumbersome. Why it became cumbersome? If I ask you for some data, it's very hard to go find it. Even today, I should say, if I go into any of the government organizations, I don't know, it might have changed now, but when I used to be in India, when I go into any big government organizations looking for some data, like for example, I was looking for my birth certificate. They would say, okay, come back after 1 week. I said, 1 week for what? Because they had to go find the book, find a ledger. They used to store in ledgers, big ledgers. So they have to go back all the way to the ledgers created in the year I was born, find that ledger, go through the month or some technique, whatever they use, find that ledger, find that page, find my birth certificate. They used to write it on a piece of paper and give it. right? I don't know if you guys still know it, but today it has changed. Okay, so the data storage slowly evolved. It was hard in terms of paper, so the storage slowly evolved to go into electronic forms. Okay, but the term electronic is very broad. When I mean by electronic today, there are multiple ways that electronic data is stored. Does anybody know a floppy disk? What is a floppy disk? I'm sure it's not in existence, but and what's the size of the floppy disk? There's, so somebody says yes, I know. Ashish says yes, I know. What is a floppy disk? Do you know what's the size of the floppy disk that was used? From at least from what I know, I think it was a 5 1/4, I believe, 5 1/4 inches. So it'll be more like a small notebook. So you might have not seen it. It was in very long. Even for me, I've just seen one. So slowly it evolved. So we started storing in floppy disk. Look at floppy disk. From 5 quarters, it became smaller to 3 and a half, I believe, 3 and a half square disk. Then floppy disk, then DVDs, then Blu-ray, whatnot. Slowly evolved. Today, data is in terms of flash drives, right? Thanks, Kahan. He says 5.5 inches. Yes, that was the first floppy disk, from at least what I know. Okay. Uh, So today data is stored in terms of sticks or flash drives. It's unimaginable how much of data is stored in that small floppy, I mean small flash drive. You know, it's a small flash drive. It holds terabytes and terabytes of data. You know, that's how data storage has evolved. That's one thing that we're gonna look at as we go down through the course today. How the data has evolved. Where did it start, and where are we today? How is it stored? Okay, now the next problem comes into effect. Even with electronic forms, as you start putting data into, let's say, electronic forms, even if it's stored, let's say, in flash drives, if I put them in a lot of flash drives, tomorrow if I need the data, again, I need to maintain somewhere to know which flash drive has this data. I have the data. See, a lot of times this happens with me. I know I have, somebody when asked me for some data, I say, I know I have that information with me, but I don't know where is it. I go into my laptop, keep looking, keep looking. I know for sure I have it, but I don't know where is it stored. Problem is because indexing. There's lack of indexing. Okay, I'm introducing a term called indexing. I'll talk more about indexing later. I'm just slowly introducing the terminologies. So I have to maintain an index somewhere, like the index in the books. How is that? Which data is stored where? That's indexing. I might say, okay, flash drive 1 has data about this, flash drive 2 has data about this. I need to maintain a separate a table or something like that to say which flash drive has what data, right? And that's called metadata. Storing data about data is called metadata. So I put in two terminologies now, indexing, and then I'm talking about metadata. Okay. So this is how data has evolved. Okay, starting from paper forms, slowly into electronic forms. Even within electronic forms, because we have the cumbersome of the metadata, which data is stored where, we went into a way of storing data in a database, which will make it easier to store and retrieve data. Okay, I use two terms now, store and retrieve. What it means, storing is basically you're recording the data. Retrieving is basically you're getting the data back. Okay, so when I talked about data evolution and data storage, I'm talking about how the data is stored and retrieved, right? So what is database? Basically, it's a base of data and a technique to store and retrieve the data. As simple as that. Okay. So it's a huge collection of data, and DBMS will talk about storing and retrieving that large amount of data. Okay. So that's about in very high level DBMS. So the next question would be, where is it used? Who is using this? You know, I'm assuming you slowly understood. If I can recap a little bit, before I go the next, if I can recap a little bit, we talked about database. I, I just said what's data. I did not really get into the details, but I just said what's data. It's just a fact or a number or a statistics, something. And then we talked about what is database. It's just a huge collection of data. And then we talked about storing and retrieving data, which is done by DBMS. DBMS stands for Database Management System. So that system takes care of how to store data, how to retrieve data. And then we talked about the evolution of data storage from paper forms into DBMS. Very simple example is YouTube. You go into YouTube, there is so much of data that resides on the database. You're just going and typing, look, I'm looking for, let's say, vector algebra. I'm just using this example. You're looking for some concept of vector algebra. In no time, in less than a minute, less than a few seconds, it goes, gets the data, and gives you the information. Wikipedia, maybe. How are they doing it? It's at the back end, there is a database. The moment you put in and say search, it's going to go back in that hits the database first and then says, look, there is a person sitting in front of me. He's asking me what is vector algebra. Tell me where is it? And then all the indexing happens. Quickly they find the database that has this information, go into the table, fetch the whole file that contains the data, throws it right on your browser. Okay, so that is where database comes into play. So everything in today's world is stored in terms of DBMS. I'll go down a little bit into applications. Applications meaning where is it used? Like I said, anybody that has large volume of data. Who is not using it? Who is handling less amount of data? For example, let's assume there's a huge supermarket. Let's use Big Bazaar. Okay, you got Big Bazaar in India. Big Bazaar has so much vast products. You go into Big Bazaar today, and then you want to buy something. You just go pick up something, and then you want to understand some details about it. Let's say you want to know the price. Assume the price is not displayed. So you take that product, you go to the front desk and say, look, I need this. Can I know the price? I want to do a price check. So somebody goes, scans it, gives you a price in no time, right? So what has happened at the background, when they scanned it, the barcode converted into a number. You have to understand the barcode has a number associated with it. So it converts to a number, and then it goes to its database, tries to understand what this number means. Okay. This number means, let's say, sunglasses. Okay, then it's another database, goes and asks for this sunglass, for this product, what is the price? It gets the price, gives you the price. Big Bazaar sells millions of products. And with no time, how do you get the price? It gets the data from the database. But let's assume you go into a store. You got a small store next to your house, let's say. You go into that store and say, what's the price? That person may be running a petty shop. You cannot expect him to go have a database and say, wait, let me check what's the price of 1 kg of brinjal. No, he doesn't do that. So there is always a win-win trade-off. What I mean win-win trade-off means the cost to implement something versus the benefit I get. I'm going to implement $1 million today to build this product. What will be my profit by doing this? I might save 5 million in the next 2-3 years. Then I'll go do it. Whereas I'll spend $1 million today, and then I'll save maybe a 500,000 or maybe only 50,000. You're not going to do that. So I wanted to make you understand who uses it and where is it applied. So the application comes into effect where there is a benefit. So the benefit applies to large businesses. Large businesses. Can I get some name of large businesses that you think of? When I use the term large business, large organizations, what strikes your mind? There's a lot of large businesses across the globe. So what are the businesses? When I look at businesses, let's use generic terms. rather than saying specific names of the companies, let's try using their domain. When I mean by domain, what they are doing. For example, IT, you know. So what are the large businesses, from what I explained so far, from what I have talked so far, large businesses that you think of who are using this database? Maybe banking, yes, iron and steel industry. People have used names. I don't really want to use names. You know, let's look at what the company does. For example, retail. I use Big Bazaar on my example. What are they into? Retail. When I mean retail, is basically they are into selling. We have Walmart. Walmart into retail business. So most of the retail industries use data. I use DBMS. Okay, so retail, banking. You go into banks. You walk into the bank. Like for example, I use the example of an ATM. They use DBMS. All the financial related companies, like stock markets, stock exchange companies, they use large amount of DBMS, right? Airline bookings. You go to try to book a ticket, airline bookings, or railway and road reservation. Even I think KSRTC has online booking. How does they do it? Online booking, DBMS. So these are some of the applications of DBMS. Okay, we'll talk more. I think there's a specific topic as I go through your material. Okay, I've not opened up your material so far, meaning in this place. I'll do that slowly. I am a hater of reading and just memorizing. Like I said, again, I'll repeat, do not memorize it. If you memorize, it's very good. You'll be the topper today, but not tomorrow. Okay, think long term, apply it long term. I'm gonna request that you do it. I have some of the people like Madhi Madam introduced. I've been involved in teaching wherever I go. Okay, it's my passion. It's not my profession. Okay, I don't do teaching profession now, but it's my passion. Wherever I go, I try to do that. Even in my current job, if somebody comes new, if they are new to the concepts, I take some sessions. I kind of try to explain, and I'm very good at that. I always look at myself on the other side. Like today, I'm talking, assuming I'm one of you sitting at Mysore or wherever you are, thinking that somebody is trying to teach me DBMS. How should I do that? So I always put myself in other shoes and think. So that way it makes it easy for me to explain things. So I walk into this assuming I don't know anything about DBMS. If I have to, if I have to understand, how should somebody? So I'm doing the same thing. So like I said, I'm going to request repeatedly, try to understand, think in your long-term job. What's your long-term career? What's your long-term goal? Think and apply there, and then we'll keep going from there. Okay. So that's why I don't really go by mugging up. I always write my own words. A lot of people tell me, you're writing your own. Yes, because I'm comfortable writing my own way. You should also start practicing it. But you should not lose the essence. You should make sure you convey the message. So for example, I said, what is database? I said, it's a base of data. If you go write this in your exam, you'll not get awarded, I believe. I'm sure Madhi madam will give you 0. This is not an answer. She'll say, no, this is 0. So that's for you to understand. And then you gotta go by your books, take your books, read it, whatever statement they use. Try to correlate what I explained. Okay, I said it's a base of data. There it explains it's a collection of large volume of stored data with the facts, figures, statistics, etc., etc. Try to understand and correlate. Create your own stories in the mind. I know Murli sir would have taken you through mind mapping concepts, I'm sure. It's a very good concept. Some people find it tough. You find it tough until you understand. It's more like your parents. Nobody likes your parents until it's too late, right? By the time you realize what your parents said is true or correct, it's too late. So don't make that mistake. A lot of times we make mistakes because there was nobody to tell us. Like I made a lot of mistakes in my life because there was nobody to tell me do this. But eventually it will happen. You will have one person in your life who will change your life upside down. Believe me. That has happened with me. There are specific people who have changed my life for the reason that I am today. Okay. So that will happen for you as well. So you got to understand and apply and correlate what I am talking versus what is in the books. And if you have doubts, you can always talk. And we'll keep talking about how to keep in touch, how to interact. Anytime you have questions, we can go through. All right. With that, I'm just gonna pick up a small example that I created. Let me bring up my screen. Like I said, some of my examples will be from what I created, and then you can correlate it to your examples or context in the textbook. So let me start sharing my screen. Tell me if you're able to. Um, I'm gonna say allow participants. Okay, share my here. I'm gonna ask somebody to just tell me if you're seeing it.
Yeah, we can see your screen. Yeah.
Perfect, thank you. All right, so this is just a very small example. So we are talking about data evolution, right? So we moved from the paper forms into the electronic forms. So in the very first time when the electronic form started, people started storing data in terms of files. So the first thing that strikes your mind when I say data in electronic forms or files is basically Notepad. That's the simplest form that you can store data. So don't look at something when I say don't look at it. Okay, so anything that's below, let's not see it for now. When I say don't see, I know everybody is reading only that. That's a habit for us. When somebody says don't do it, we start doing it. So I'm gonna ask don't read what's below. So let's look at, and I try to gather some information. So this is like the student information. I know tried to use some of the names. You may be surprised. How did this guy know my name? So I got to use some of your names, maybe not all. I got Bharat, Manjushri, etc., etc. So what I've done here is I've just created a student information file. Assigned you a student number and your name and your gender. I just put male, female, gender, and then this is the date of birth. Excuse me, I don't have the right data, plus I don't want to put your information on this place. So I'm just assuming I put some date of birth, assuming XXX, whatever. I assume I use the right year, and then your address. These are different information. Basically, let's assume Murli Sara Madhvi madam wants to store in the college. So this is how, if you don't have database, this is how we must have done. Just go into a file, start writing randomly. So this is a random thing. There is no row, there is no column here. The data is stored in terms of records. I don't use the term records, but I'll still use it because it's each line, I would say. Okay, the data is stored in terms of lines. Otherwise, internally, if this data will be stored like this, if you have studied computer architecture, this is how data would have been stored. There is no wastage of space. If you talked about data architecture, how data is stored and accessed in files, this is how it is stored. Assume the data is stored like this. If I could change if I take the word wrap off, what doesn't help. Okay, this is how data would have been stored. Now today, if I quickly ask you, okay, what's the date of birth for, let's say, use some name Rohan. What's Rohan's date of birth? So you're gonna jump into this file and start first looking for where is Rohan. That will take me 2 days time if there is a huge database. Okay, I keep going, I do a search, okay, I find Rohan here. Okay, now next question is where is Rohan's date of birth? Now I'm gonna go through, okay, the record starts here, so I don't know where it starts, let's say it starts here. So I'm gonna go through all these records, okay, there I go. There I find Rohan's date of birth. Now, after I find the date of birth, then I go give that information. So now if I have to do this for about 100 people, it's very cumbersome and it's not in a readable format. Okay, so for that, we would prefer to have the data a little bit organized. Let's say we used tab separated or comma separated file. Now this is where we are going into a little bit more organized. Okay, at least this tries to help me. Even here again, remember the data is still in terms of a file. Okay, still have to go through each of it and find where is Rohan's name or anybody's name, find the information. At least it is in a presentable format. This is how data was stored to start with. So people found it more and more cumbersome. Now they started thinking, how do we go about this? Now, where was it even more difficult? this information talks only about your student number, your name, your gender, your date of birth, and your address. I want to store your marks, let's say. There are exams over, everybody passed out with a A plus. I don't know whatever grade, but 100%, let's say everybody passed out with flying colors. Everybody's happy. So you come back to Madhi madam and say, look, this is what I passed. Assume everybody got 100% in math. Everybody has got very good marks. So now Madhi madam is very happy, but she has to record it somewhere. What does she do? She opens a new, she wants to put that information here. But as you start typing more and more information, more and more information here. So now I got to start typing your marks, let's say, I put whatever marks here. And then by subject wise, I keep typing subject wise marks. So the length of the record keeps increasing. And then tomorrow you come back, you say, okay, you got a good job in a company. She wants to store that information. So the record keeps growing and growing. And as the record keeps growing, as the storage increases, as the level of storage increases, your retrieval becomes difficult, right? So that is where what Madhvi madam will do. Look, I'll create another file and then I'll put that there. So she's going to create, let's say, a marks file, a file separately for marks. Is this file still sharing? I just opened up a second file with marks.
No, we are still with the previous screen, the
Okay.
first one that you shared.
Okay, so I'm gonna share the marks file. If I, okay, here it is. Now I think it should be. I'm assuming yes.
Yes, yes.
Okay, perfect. So here is this second file. So Madhvi madam goes creates another file. For each student, she's storing the marks. So student number. Now she can identify people with student number, or she can even use name. Okay, student number, student name. She puts all your marks here. Whatever subject, let's assume. I just use some examples. I may be wrong here. Just use some examples: English, physics, chemistry, biology, whatever, computer science, all those subjects. And then she computes an average. And this is how we use the second file. So far we talked about two files. One is the basic information. Second is about storing individual marks. Now the question comes, somebody is coming and saying, can I get this grade? Somebody's grade. Okay, so now I have another file I'm going to share with you called a grades file. I'm going to share the grades file. Let's do that here. Okay, so this is the grades file. What the grade file does is it stores no other details, but just general information about the mark and the grade. So this is telling if somebody has got 100% to 95% average, that's an A plus grade. So, and somebody has got, let's say, 94 to 90%, it's an A grade, etc. So now we got three files: a base information or a student information, then we got a marks file, then we got a grade file, then tomorrow I might create another file for your job. Let's assume you come back and say you got a job. I want to store that information. That's another file. So what happens here is just for one single thing, just for one set of information, we are creating multiple files. This is still in existence. Okay, this is not gone away, but this still exists. People store small chunks of related information. These are all related information. Now I'm introducing another terminology, underline that. Related information. So these are all related information about one set of classroom. Their name, their marks, their average. They're stored in separate places. Now, assume I walk into the school tomorrow and say, okay, I want to know people who have got A plus grade. Now you have to access through three different files to get it. First, you go to the first file, get the name, student number. Second file, you get your student number. With that student number, you get all the marks. Then open a third file. So it is cumbersome, right? So how do I avoid this? Any guesses? Anybody wants to take a guess? How do we go? I'm still not into DBMS, so don't think too big, too beyond. So now, how do we go? What's the easier form to store data? So I'm gonna open up another. Meanwhile, you're open to chat or ping. I'm gonna start doing a new share, something like this. Okay. So assume I go into this format. So I go create a table and pulled all the data in the table. Now I've combined all the information here. So I've put student number, I've put a name, I've copied the gender data. So what you see here is from the first table, and what you see here is data from the second table, and what you see here is from the third table. So all this data resides in one place in the form of table, right? So this is the conversion. So this is the evolution that we're going to talk about. So how the data converted from that files into these tables is what we're going to talk about as we go through this. So there is a process that we need to follow to convert that file format into a table format, right? It is not just like, you might think, a lot of you, I know, I'm sure, thinking, this guy is talking, it's not big, this guy is talking very simple. He took all the data, put it in a table, and he's saying this big thing. It is not that simple. It's as simple as thinking driving a car is easy. Driving a motorbike is easy. We might think it's easy, but it's not, okay? So there is a lot of rules and principles that we need to follow to convert that data into this format, which I'll talk more as we go down the line, okay? Now we got another 3 minutes before we wind. So I want to take a short break. I know I really want to give you 10 minutes, but I know we spent a lot of time this morning or this evening for you. It's morning for me, talking through some of the basics. I really felt that's needed. Like I said, I'm a people developer. I'm very interested in motivating people. If somebody is bored or dull, not knowing what to do, ping me privately. We should talk. I will charge you up 101%. You will be super excited. Okay. If you're not excited, that means you are lacking some sort of information. It's not that it's tough. Nothing is tough. Believe me. Okay. For me, every single thing that I have achieved today, if I turn back and look, it was difficult. Okay. Today, when I talk to my friends or my family, I tell them, I never thought I'll do this. I never thought I could drive a car. I never thought I could drive the opposite. When I came from India to here, it was very difficult to me. In India, it's keep left, it's keep right here. It was very difficult. I thought I'm not going to do this, but things change. Okay, so it's possible. So if you think something is difficult for you, you can talk to me through Murli sir or Madhvi madam. Come through them, or we can talk. I can charge you up. Okay, I want to reserve the next few minutes. I got a next meeting to run into, but I can give you some time. I really want you guys to open up. I told it has to be interactive, and only I've been talking. Let's open up this for some time, and I can stay here for another 5-6 minutes. I want you guys to either ask me questions or give me something or talk something. It could be anything. Okay, feel free. I'm sure Madhvi madam will not mistake if you talk anything outside DBMS. So feel free. I'm gonna open up, or you can also open up the mute. It's your ground. Go ahead.
Students, you can feel free to ask your questions, doubts I'm sure you have a lot of in your mind. Feel free to ask, no problem.
Hello, sir. This is Gehen Pradhan.
Hey, Gahan.
Sir, I wanted to just know that what are the different type of DBMS? Are there any types also in this?
That's a very good question. Very good. Thanks, Gahan. First thing, I appreciate you asking. Always the first start is a tough start. Somebody has to open it up, right? So appreciate you for that. Yes. So there are types of DBMS, meaning, so we just talked about data and database. I've really not gone into more about DBMS. Like I finished saying, there are different techniques in which the data is stored. If you remember, I used the term related data, and when I said that, I said underline that word related. Okay, because today I'm talking about DBMS. Tomorrow I'm going to call it relational DBMS. It will get an additional name to it, relational. Why relational? That I'll explain as I go down. To answer your question in short, yes, there are multiple types of DBMS. What are the types? Basically, we talk about relational, hierarchical, network, a lot of other forms, not only those three. It comes from the way the data is stored. How do we store? I showed you the data is stored in terms of tables. That's called relational DBMS. There are also other ways the data is stored. So based on the way it's stored, there are different types of DBMS. I will take this question, and I think probably another couple of days, or maybe tomorrow, day after, we'll talk about the types and why they get that name. Okay, but yes, it's a very good question. But to answer, yes, there are multiple ways. I mean, multiple DBMS, and we will study about 3 of the major DBMS covered in your curriculum in the coming days.
Thank you, sir.
Sure, you're welcome. Anybody else? You gotta open up and speak. That's again another important thing. Don't be shy. Nobody's gonna say it's no question is wrong question. Can ask anything.
Okay, I think the students will take some time to
Sure.
open up. Fine.
Sure. No problem. So I think with that, if there are no other questions, I'll quickly finish. So today we just covered about what is data, what is database, and how the data has evolved, and a little bit about electronic forms and how data is stored. Just remember these, and then tomorrow we'll just do a quick brush up, and then we'll go from there.
Right.